Hello everyone, welcome back. Hopefully the quiz went well. I'm making this video before the quiz, so I'm not quite sure how it all worked out, but hopefully everything went well in the quiz and everyone was confident in how they did. So we have on here our next section posted for you, which is volume of prisms and cylinders. So we're changing a way of thinking from area, when we are talking about covering something, to volume. Volume is the amount of space inside an object. We're now talking about filling something inside an object, and it's always measured in cubic units. You notice I put that in all caps because our label is going to change now. When you look at the picture of these purple cubes, you see what we mean by filling something with cubic units. It's the amount of cubes that fit inside of a space. And this is going to be a lot of formulaic work and a lot of knowing your formulas, but you'll be able to have your notes, so you'll be just fine. So for these prisms and cylinders that we're going to look at today, we're going to have a formula for volume. And that formula for volume is always going to be simply base times height. But when you see that base, it looks different. It's a capital B. And that capital B actually stands for the area of the base. It's not just the base itself. It's actually the area of the base shape. Because if you remember, a prism is made by taking two polygon bases and connecting them by rectangles. So the length of the rectangle, or the distance between the bases, is going to represent the height. And you find the area of the base and times it by that height. So let's go ahead and look at a couple of these. All right, in example one here, we're looking at a rectangular prism. And so rectangular prisms are actually a little bit different in the way that when we go to work with these, when we go to find this area of the base times the height, this has actually 6 rectangles for its faces. So you can use any rectangle as the base. In this case, we'll use the bottom, and that's just where most of you are more confident in calling it the base. So we're going to call this rectangle here on the bottom our base of our rectangle. So the area of the base is found by taking base times height, 6 times 1, so the area of the base is 6. Now the height of the object is always the distance between the bases. So if we declared the top and bottom as our bases, then the height must be 4. So in order to find the volume, you do the area of the base times the height. 6 times 4 is 24, and we would call those yards cubed, cubic yards to the 3rd power, because again, we are filling that shape with cubes. All right, so that's a rectangular prism. A lot of you might have done volume of a rectangular prism before, and you might have been taught things like length times width times height, which does work, and that will work for all rectangular prisms. But we're going to stick with a formula that works for all prisms and cylinders. So we're going to stick with the area of the base times the height. So let's look at an example where the area of the base matters. And so we have a trapezoidal prism here. So remember, a prism is a polygonal base connected by rectangles. So our polygonal base here is represented by a trapezoid. So that trapezoid is going to be our base. So in order to find the area of the base, we have to use the formula for the area of a trapezoid. And if you've forgotten what that is, that's 1/2 B1 plus B2 times H. So to find the area of the base, it's 1/2. Your bottom of your trapezoid is 5. The top of the trapezoid is 8. We add those together, cut it in half, and times it by the height. Remember, height needs to be a vertical distance straight up and down. So that dotted line that I just colored in blue is the height of the trapezoid. So that needs to be 2.6. So we plug in our height at 2.6, and that becomes a calculator problem now. And the area of our trapezoid works out to be 16.9. All right. Now the height of the object is the easier part. That's the distance between the bases. How far it is from one trapezoid to the other. So those are all the heights of the object. And so that's 10 going across there. So in order to find volume, we have to take the area of the base, 16.9, times the height, which is 10, making it 169 cubic feet. So this is all very formulaic. You find the area of the base, times it by the height, the distance between the bases, and that gives you your volume. All right, the same formula applies for all prisms. And the same formula also applies for cylinders, which brings us to our third example. In order to find the volume of this cylinder, we have to find the area of the base. And remember, base does not necessarily mean bottom. Base is the part that is connected by rectangles in a prism, and the cylinder, the base, is always the circular part. So let's go ahead and start by finding the area of the base. And because the bases are circles, we can do pi times the radius squared. And remember, the two bases are always going to be identical, so it doesn't matter which circle you select. So we take pi times 2 squared, which is 4. So we do pi times 4. And that will give us the area of the circle on our base. And that is 12.6 square units, or square centimeters. The height of the object is the distance between the bases, which in this case is clearly 4. So in order to find volume, we just take 12.6 times 4, and that gives us a volume of 50.4, and that's always labeled in cubic units. So that's cubic centimeters. So if you understand your area formulas, volume for cylinders and for prisms is fairly simple. Find the area of the base and then times it by the height, which is the distance between those two bases. All right, good luck. And if you have questions, make sure you post them to us on Schoology.